Hello everybody, welcome back to my channel. Today's video will be seeing sorting algorithms. We'll be seeing three types of sorting. One is bubble sort, one is selection sort, and one is insertion sort. We'll be seeing the code and example tracing for each of these. Let's start with bubble sort. First, tell you what it is. So what in bubble sort we do is we compare adjacent numbers. If the left number is greater than the right number, then we swap. Then we go to the next two numbers. Again, we check if the left number is greater than the right number. If it is, then we swap it. This is continued throughout the array until the largest number is bubbled at the last. Okay. Now, let me write the code for it. I'll take a sample code. I will not take too much heavy numbers. Slight numbers I'll take. Hash include stdio.h int main int of 6 I'll take. This number only I will write there also in tracing 27, 14, 35, 9, 18, 5. Int n I j. I'll just set n equals to 6 here itself. I j temp. Okay. Now the main logic. So pay attention. Main logic. For I equals 0, I less than n minus 1, I plus plus. For j equals 0, j less than n minus I minus 1, j plus plus. If of j is greater than of j plus 1, then temp equals of j, of j equals of j plus 1, of j plus 1 equals temp. Close all the three brackets. Then printf percentage d comma, for loop I forgot, right? For I equals 0, you can write printf sorted array. Then printf I equals 0, I less than n, I plus plus. Printf percentage d comma of I. Then return 0 and close the bracket. This is the code. Let me cross check for any mistake. For I equal to 0, I less than n minus 1, I plus plus. For j equal to 0, j less than n minus 1 minus I, or I minus 1, same thing, j plus plus. If r of j is greater than r of j plus 1, either you can write swap r of j and swap r of j plus 1, or you can write it the way I have written. Okay. So, hope you have understood this one. Now I'll take an example, the same example I'll take. Temp equals r of j plus 1, r of j plus 1 equals temp. And then I'm printing the sorted array. This is bubble sort. Now same question I'm doing tracing for easy understanding. Please pay attention. 27, 14, 35, 9, 18, 5. First pass, okay. I'm comparing 27 and 14. 27 is greater than 14, so I will swap. 14, 27, 35, 9, 18, 5. Next, I'm comparing 27 and 35 adjacent elements. 27 is less than 35, so I will not swap. I will keep it as same. 14, 27, 35, 9, 18, 5. Next, I'm comparing 35 and 9. 35 is greater than 9, so I will swap. 14, 27, 9, 35, 18, 5. Next, I have to compare 35 and 18. 35 is greater than 18, so I will swap. 14, 27, 9, 18, 35, 5. 35 and 5, 35 is greater than 5, so I will swap. 14, 27, 9, 18, 5, 35. Now this 35 is the largest element that we can see, and it is bubbled at the last. So this we will not touch from the next pass onwards. Let's go to the second pass now. I'll just read the same thing. 14, 27, 9, 18, 5, 35. 35 we won't touch. 14 and 27. 14 is less than 27, so it will stay the same. 14, 27, 9, 18, 5, 35. Next 27 and 9. 27 is greater than 9, so we'll switch it. 47, 9, 27, 18, 5, 35. Next 27 and 18. 27 is greater than 18. So 14, 9, 18, 27, 5, 35. 27 and 5. 14, 9. Again 27 is greater than 5. So 14, 9, 18, 5, 27, 35. Now 35 is already sorted. We won't touch it. We won't compare with that also. And we not require also. Now this also is sorted. Now let's go to the third pass. 14, 9, 18, 5, 27, 35. These two are sorted now. So we will not touch that. 14 and 9. 14 is greater than 9. So we will swap it. 9, 14, 18, 5, 27, 35. 14 and 18. Is it required to swap out? No, because it's 14 less than 18 itself. So 9, 14, 18, 5, 27, 35. This is already sorted. Next 18 and 5. 18 is greater than 5. So I will swap it. 9, 14, 5, 18, 27, 35. Now this should I check with this? No, because it's already sorted. Now 9 and now fourth pass. 9 and 14. Write it again and check. I'm just showing. 9 and 14. 9 and 14 is required to swap? No. So 9, 14, 5, 18, 27, 35. Next 14 and 5. 14 is greater than 5, so it's required to swap. So 9, 5, 14, 18, 27, 35. And this also will be sorted. Coming to the fifth pass. 9 and 5. 9 is greater than 5, so I will swap it. 5, 9, 14, 18, 27, 35. All of this is sorted. Now this also becomes sorted. So this is the final sorted array. Final sorted array. Okay, done. Try to explain a detailed question very slowly. I have explained, so I hope there is no doubts in this. Okay, let's go to the next type, that is selection sort. In selection sort, what we do is we select the number which is smallest, we put it as minimum index, and then we swap it with the first element which is not sorted. Again, after that, again we search the smallest element, again we swap it with the element which is the first element which is not sorted. Okay, that is the main idea. I'll write the pseudo code first and then I'll proceed. Tell code only I'll write hash include stdio.h int main int of this also I'll take 6 only equals 21 8 30 12 5 16 int n I j temp min index, same as above but min index is extra. This n equals to 6 I'll keep. Okay, now main logic. For I equals to 0, I less than n minus 1, I plus plus. This is same as the above. Above also for I equals to 0, I less than n minus 1, I plus plus 0. That's one technique to remember. Bubble sort and selection sort, same first lines. Here you have to write min index equals to I. Then for j loop, for j equals to, now what you should write, you should write j equals to I plus 1. Okay, I plus 1. Correct? Yes, for j equals to I plus 1, j less than n, j plus plus. Now one if condition is there. If r of j is greater than r of j plus 1. Sorry. Greater than r of min index. The previous one I got mixed with it. R of min index. First we did for I equals to 0, I less than n minus 1, I plus plus, min index equals to I. Min index equals to I. After that, for j equals to I plus 1, j less than n, j plus plus. If r of j is greater than r of min index, then min index equals j. Correct? Now I am just going to close the first if loop and the j loop. But the first for I loop is still there. Then I am going to write temp equals to r of j. R of j equals to r of min index. R of min index equals to r of equals to temp. Temp equals to r of j. R of j my bad, it's r of I. R of I. Temp equals to r of I. Tell you 1 second, don't get confused. For I equals to 0, I less than n minus 1, I plus plus, min index equals to I. For j equals to I plus 1, j less than n, j plus plus. If r of j is greater than r of min index, then min index equals to j. We have closed both the loops. So where will j come from? J will not come from. We have closed both the if loop and the j loop. See, we have closed it. J will not come here. Then temp equals to r of I. R of I equals to min index. R of min index equals to temp. Now I'm going to close this also. Then for loop, for I equals to 0, I less than n, I plus plus, printf percentage d, comma, r of I. Return 0. That's it. You can write printf solidarity, all of that. Main idea is this. J equals to I plus 1, don't forget. And here is j less than n. This here is I less than n minus 1. Once again, I'll quickly brief up because there was quite some confusions. Write the main logic part. For I equals to 0, I less than n minus 1, I plus plus, min index equals to I. For j equals to I plus 1, j less than n, j plus plus. If r of j is less than, there are greater than there. No, it should be less than. This is which one? Minimum index type. So less than, my bad. R of is less than r of min index. Then min index equals to j. After that, I'm closing the brackets. After that. Then I'm going to write. Temp equals to r of j, r of I equals to r of min index, r of min index equals to temp. That's the basic logic, main part, which I read it because there was some confusion. Now let's go to the tracing part. Simple example: 21, 8, 30, 12, 5, 16. Now I'm going to have to set the smallest index. Compare 21 and 8. First 0, 1, 2, 3, 4, 5. First compare 21 and 8. Min index currently is what? 1. Compare 8 and 30. Min index is still what? 1. Compare 30 and 12. 8 and 12. Min index is still 1. Compare 8 and 5. Min index becomes 4. Compare 5 and 16. Min index is still 4. we found out the smallest element. Do you understand how did we find this? Just you can write it if you want, or else just it's better to write it if you want. Okay. Now 5. I'm going to swap it with the first answered element, which is this. So 5, 8, 30, 12, 21, 16. Now this we will not touch. We will not touch that. Go to the next. Same 0, 1, 2, 3, 4, 5 you put. Now compare 8 and 30. Min index is what now? Compare 8 and 12. Min index is still 1. Compare 8 and 21. Min index is still 1. Compare 8 and 16. Min index is still 1. So I'm going to swap this with the first answered element, which is already that itself. So no change. So 5, 8, 30, 12, 21, 16. Now these two are sorted. I will not touch this. 0, 1, 2, 3, 4, 5. Next 30 and 12. The min index is 3. 12 and 21. The min index is still 3. 12 and 16. The min index is still 3. So I have to swap 12 with the first answered element, which is going to be 30. So 5, 8, 12, 30, 21, 16. I will not touch 5, 8 and 12. So 0, 1, 2, 3, 4, 5. Compare 30 and 21. The min index is 4. Compare 21 and 16. The min index is 5. So I will swap 16 with the first answered element, which is 30. So 5, 8, 12, 16, 21, 30. Now I will not touch these. So 0, 1, 2, 3, 4, 5. Now 21 and 30, the minimum index is 4. I have to swap with the first answered element, which is that itself. So there is no change. So 5, 8, 12, 16, 21, 30 is the final sorted array. Because after you write 21, then with 30 you know to compare. These 5 is already sorted. So 30 you not compare, so I'll be the final answer. So it's also try to explain step by step the tracing. Hope I've made it easier. Hope I've made it explainable as well. So now let's see the next one, which is insertion sort. First for me, this is the hardest of all, though I've made mistakes in selection sort as well. But anyway, let us see the coding first. In insertion sort, we compare the one element with all of the other elements, and then we don't swap here, we switch it. Not switch, I mean shift it. My bad. We shift it. Don't swap it, we shift it. That word is extremely important here. So hash include stdio.h int main int r of 6 equals to 32, 7, 19, 25, 11 and 4. Int n equals to 6, I, j, key. Here temp is not required. Here key is there. Now see, for I equals to 1. Before it was I equals 0, I less than n minus 1, I plus plus in the previous two codes. Here it is I equals to 1, I less than n, I plus plus. Two lines we have to write. The first line is key equals to r of I, and one more is j equals to I minus 1. Then for j equals to j, not for, my bad, while. There's only one for loop in this question, in the sorting. While j is greater than or equal to 0 and r of j is greater than key. Again, two conditions. First is r of j plus 1 equals to r of j, and one is j minus minus. I'm closing the while loop. I'm not closing the for loop yet. I'm going to write here r of j plus 1 equals to key. Now I'm going to close the for loop as well. Now print for I equals 0, I less than n, I plus plus, printf percentage d, comma, r of I. Return 0. Did you understand? First learn the code, then understand how it's working. For I equals to 1, I less than an I plus plus, two sentences. One is key equals to r of I, and one more is j equals to I minus 1. Did you understood? Then while loop. Here only one for loop and there is no temp or anything here, just for there. Now while j greater than or equal to 0, remember greater than or equal to 0, and r of j is greater than key, r of j plus 1 equals to r of j. Then you have to write r of j plus 1 equals to key. Okay, here it is j minus minus, then r of j plus 1 equals to key. Then the sorted array we are printing. That's it. This code what I've written looks correct to me. Hope I've not made any mistake. I've crossed it also. By mistake you have said something what I've written correctly, please don't mind. Okay. So the next example is 32, 7, 19, 25, 11, 4. 32, 7, 19, 25, 11 and 4. Here what are we doing? First we're considering this as the first element. Now we're comparing 32 and 7. 32 is greater than 7. Yes, so I'm going to shift it. You know how I'm going to shift it? First write like this. Fine. Then compare 32. It's going to come like this. That's why I said shift it. Next compare 32 and 19. 32 is greater than 19. So 19 has to shift. So how will it shift? It will shift like this. 25, 11, 14. Next compare 32 and 25. Again 32 also is greater than 25. So that also has to shift. How will it shift? Just same way. 25, 32, 11 and 14. Now compare 32 and 11. Again 32 is greater than 11. 17, 19, 25, 11, 32 and 14. But 11 is greater than 25. 25 is greater than 11 also. So that also has to shift. So here, better, don't write 11 here. The final one you write just for showing purpose. 7, 19, 11 place this is 25, 32, 14. Basically it's 11 place only. Just showing how it is shifting. Because it's not shifting here, right? It's going to shift before 19. That I'm just trying to show here. And 19 is 11 also. So that has to also shift. So 7, 11, 19, 25, 32, 14. Now just showing purpose. Next 32 and 14. Of course 30 is greater than 14. So I have to swap, shift. Okay, shift. That also 17, 11, 7, 11, 19, 25. This is 14's place and this is 32. 24 is greater. So 7, 11, 19, 14, 25, 32. Then again here I have to shift 7, 11, 14, 19, 25, 32. Then you get your final sorted array like this. Did you understand how it's working? I hope you have understood it. So we just compared. Okay. Then we are shifted. Now, like each part you have to go on making it standardized. Like I'll give you another example for just insertion sort. 12, 85, 59, 45, 72 and 51. First 12 and 85. 25 is an 85, so it is sorted. Now 85 and 59 I'm going to compare. 59 is less than 89, so we have to shift it. So 12, 59, 85, 45, 72, 51. Alright. Now 85, now you can consider this much as sorted for now. This much is sorted only for now. Next consider 85 and 45. 85 and 45. 45 is less than 85, so it has to shift. 12, 59. For now I'm just writing for your understanding the 45 here. 85, 72, 51. But 45 is 59 also, so again it has to shift. 12, 45. You can write it like this also. And I put it in box format also. 85, 72, 51. Next, now you can consider this much is sorted. Then for now, then again 8. Or don't put sort again and again. You can just write how I did the previous one. 85 and 72. This has to come here. So 12, 45, 59, 72, 85, 51. 85, 51 again. So 12, 45, 59, 72, 51, 85. But again, this will not come here. You can write it or leave it. But 12, 45, 59, 51, 72, 85. But still it won't come here. It will come here 12, 45, 51, 59, 72, 85. You can see this is the final sorted array. So 12, 45, 59, 12, 12, 45, 51, 59, 72, 85. So this was how we did it. You can consider an easier way also. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 iterations you can see we have used here. This being the standardized question. Like just basically understand. There's different ways you can represent it, but just for understanding, I've shown you this. You can write here what is greater than, how we are shifting, or you can write it in your own words. So I've tried to explain bubble sort, selection sort, and insertion sort in this video. So hope it has helped. Thank you for watching. See you in the next one.